All right, so I'm going to show you some easy angle relationship examples, starting with pretty easy and ending up with, a little bit harder. The next video I'll show you some more difficult ones. Okay, so when we're doing problems, it's good to get into the habit of doing them step by step, line by line, saying what you know in terms of the angle names, and then plugging in values later. Okay, and then put the reason why you can make each statement, right? So we'll say, like, I'm going to make some statement and then justification for that statement, because you can't just say something all willy-nilly and can't be like, well, it's common sense. You say a statement and then because of some reason that that's an acceptable law, axiom, theorem, things like that. Okay, so here's the first one. We have angle ACB and angle DCB and that's pretty much it. I have those two angles. Okay, and I want to figure out this angle. Well, what does this drawing show me? Well, the first thing that it shows me is this little blue square down here. This little blue square indicates to me, let me focus that back up, indicates to me that angle, I'm going to call it ACB, angle ACB is a right angle. Okay? Because that is given to me with a symbol. Right? That's the first thing I'm going to tell them. Okay? And because it's a right angle, right, what do I know about the measure of angle ACB? I know that it equals 90 degrees because that is the definition of a right angle. This is the sign for angle. It's like a slanted L, but it's supposed to be an angle. All right, notice how I named it with the vertex or the vertice as the middle letter. That's important. Okay? All right, so if I know that this is 90 degrees, it also tells me that the measure of angle DCB equals 30 degrees. That is given. Okay, so now all that stuff has been given to me. All right, and now because that stuff is given to me, I can make my first relationship statement. Okay, that's important in identifying the relationships, and I'm going to do so with just letters to identify. I'm not gonna talk about 90 degrees and 30 degrees, and it should be pretty obvious what this angle is right now, right? But let's show how we know that. We got to prove how we know that, right? So I can say that the measure, I think I'm using ACB as 90 degrees. The measure, I don't know why there's a little dot there. It's not mass flow rate. The measure of angle ACB is going to be equal to, and it's equal to the angle of ACD, which is purple here. The measure of angle ACD, which is the purple one, which has a question mark, plus the measure of angle DCB. So my purple angle plus my red angle equals my blue angle. Okay? So now, if I want to figure out what this purple angle measure is, so what allows me to say this statement, which is the most important statement of this thing? Well, this is, let me change it to a red or black. So this is because of the angle addition postulate. Okay, that's a rule, right? I've applied the angle addition postulate in this scenario to make that statement. All right, so I'm going to rearrange this algebraic equation to solve for my purple angle here. So the measure of angle ACD equals, I'm going to bring this over to, we'll bring this over to here and make it negative. We'll just bring the red over to that side. Okay, so bring the red angle over to that side, so the blue angle stays. A measure of angle ACB minus, it's plus on this side, so it's going to be minus on this side, minus the measure of angle DCB. Right, so that's that. And why can I say that? Well, that's algebra. Algebra specifically, it's the subtraction law of equality, but algebra is good enough for me. Okay, and now because of that, I can finally do some substitution here. I can say that the measure of angle ACD equals my blue, which is 90 degrees, minus my red, which is 30 degrees, and 90 minus 30 equals 60 degrees. Right? So this is the solution, right, for a very, very simple question. Okay? And why can I do this? Well, this is substitution and a little bit of arithmetic. That's probably not spelled right. Okay, a substitution and arithmetic. All right, so that's the first one. Let's go ahead and start with the second one here. I'm going to pause this and change this around a little. Give me some more space to write. All right, so I gave myself some more space and remade a similar thing, right? So first thing it says is that given points A, B, and C, points A, B, and C are collinear. A, B, and C are all on the same line. Okay, because those are all on the same line, right? Or another way this could be, another way that this could be written is, you know, point C lies on line AB, right? So there's another way that you could write that. Either way, those are two ways to write the same thing, saying that A, C, and B are all in a straight line. Okay, so because they're all in a straight line, you can say that the first statement you're going to make is that angle ACB, with the vertex B and C, is a straight angle. S-T-R-I-G-H-T. S-T-R-I-G-H-T is a straight angle, right? Which is important, right? Because we know straight angle is a straight angle. Okay, so this is because it is the definition of a straight angle. Okay, and because of that, I can say that the measure of angle ACB equals 180 degrees, and that's because of the definition of a straight angle. Okay, so those are, I've already established that this from here all the way to here is 180 degrees. Okay, so now I'm going to go ahead and make my first major relationship statement. Okay, I'm going to say that the measure I'm just going to say that the angle ACB, when I say measure, right, I'm putting numbers in, okay? Angle ACB is going to be equal to angle ACE, which I'm going to make red. Angle ACE plus this blue angle, angle ACB. ECB, excuse me. ECB. All right, and this is angle addition postulate. Okay, so now if I'm trying to figure out this blue angle, I'm going to rearrange my equation to solve for the blue angle, saying that angle ECB is what I'm trying to solve for, equals my big angle, 180 degrees, my angle ACB minus my red angle, angle ACE. Because of algebra, I just rearranged the top equation and then just plug in the numbers here. Measure of angle ECB equals 180 degrees minus 140 degrees, which equals 40 degrees. So that's 40 degrees. And that's how I'm able to conclude that. Okay, so hopefully this video makes sense. It's been 11 minutes. So we're going to move on to a little bit more complicated ones and use Latin letters, Greek letters to identify angles instead. Because I think you might see it's a little easier. Okay, moving on to more complicated ones in the next video.